Hello and welcome back to the channel. My name is Eddie Jennings from ejsllc.com. This video is going to be the first of several that are going to be RHCE practice session videos. And before I dive into them and explain what I'm doing here, I want to thank returning subscribers for watching another video, as well as invite everyone, if you have not subscribed yet, make sure you click that subscribe button and ring the bell when you do, so you can be aware of when new content comes available. Also, don't forget to like the content if you enjoy it, and feel free to leave comments and share it with others that might find it useful as well. So as mentioned in the introduction video, this video is going to be a practice session where I'm not necessarily trying to give authoritative information and make this a tutorial, but rather I'm preparing for the exam. I'll be taking it in about a month or so, and I am doing my final review where I'm going to go through all of the objectives that are posted on Red Hat's website and attempt to explain what the objective is talking about, or do some examples and such, just as a test to see if I feel like I'm confident with the objective and am ready for the exam. Some videos I'm probably going to sound more confident than others, and that'll give me an idea of what I need to practice a bit more before I take the exam in August of 2021. So without further ado, let's dive into it. So on the RHCE exam, they have their objectives that are grouped into various sections. And one thing I like about this exam and the Red Hat exams in general, at least the ones that I have worked with, which is RHCSA and RHCE, is the RHCE kind of builds upon RHCSA. And so all of these are performance-based exams, so you're going to have to do actual tasks and such rather than just, answer multiple guess questions and the like. And so I like that. And for RHCE, you can't possibly do well with this exam without understanding the concepts of RHCSA, which I think is a pretty big plus. The idea behind these two exams together is, you're learning fundamentals and such with the RHCSA, and then with RHCE, it's time to take those fundamentals and see if you can automate them. So with that, the first objective that we're going to be looking at is under the be able to perform all tasks expected of a Red Hat Certified System Administrator section, and that is understand and use essential tools. If you were to look at the RHCSA objectives, basically all of the objectives in here are the groups of objectives that you had for the RHCSA exam. So I'm going to go through actually the RHCSA equivalent of these really quickly. This isn't going to be, or hopefully it's not going to take forever, as I should be pretty familiar with these. So if I go back to RHCSA, one of the first objectives under the understand and use essential tools is to be able to access a shell prompt and issue commands with correct syntax. So I'm here with a Red Hat Enterprise Linux 8 workstation, and to be able to access a shell prompt, you can simply go into activities and click terminal, and you're in a shell prompt here. It shows me my user at the name of the host and the current directory that I'm in, which is my home directory. If I were to do pwd print working directory, we see that I'm in /home/Eddie, and that's really about it. You have to be able to obviously issue commands with correct syntax. If I were to do something like, pwx, that's not a command. So you have to spell your commands right. And, even though you'll be in a RHEL environment for your exam, because, obviously you're using actual Red Hat, and I would imagine that there's probably going to be a workstation like this to where you would have a GUI, you can go into the terminal. Otherwise, if you don't have a GUI, then you're obviously going to need to be familiar with doing things at the shell and at the command line. So the next objective is use input-output redirection. And again, this is from the RHCSA exam, but it falls under the use and understand essential tools, which is a part of RHCE. And input-output redirection, this isn't too complicated of a thing. If I were to do echo, or let me get back in focus here, echo the quick brown fox jumps over the lazy dog. If I were to echo that, that's the statement, and it comes out to standard output, which is what we see here in the terminal. So the idea of input-output redirection is, rather than having this come out to standard output, we're going to send that somewhere else. So if I were to press up, it gets back to that same command. And if I want to send that that standard output to a text file, I'm just going to call it foo.txt, I would use the greater than symbol. And notice we didn't get any output this time. And if I were to cat foo.txt, we're going to see what we would have echoed. That's an example of output redirection. Now, there are some things that are not actually coming out to standard out, such as if I were to do that pwx command again, says, bash command not found. If I were to do that and try to send that to foo2.txt, and if I were to cat foo2chat, if I were to cat foo2.txt, we see there's nothing there. And that's because what this is actually an error. An error has its own, I believe it's called a descriptor. And so if we wanted to send, let's say we're doing a script and any errors or anything that goes to standard error, we want to output that to your file, you would use the to and then your redirection. And I'm going to call this foo3.txt. And we see now there was no output because the standard error that would have been there was sent to the text file, and we can use cat to confirm that. There's our bash text not found. Now there may be some times where you want to send your standard error to standard output. This I actually haven't done in a while, so this might be my first example of having to think through how to do it, but we'll see how this works. So if I wanted to capture standard error and send it to standard output, I believe this is where our 2 and 1 comes in. So if I were to do pwx 2 and then go and 1, I believe that's going to send that to standard output. And it did. So if I were to do that and then send it to I'm trying to think how I can make an example of this. Oh, maybe I'll write a quick little script. So let me do test.sh, and I'll get into scripting a little bit later with one of the objectives, but we're going to do a quick test here. I'm going to do pwd followed by pwx, and that'll be it. So if I were to make that executable, change mode plus X. If I were to run this, okay, good deal. So I have some standard output as well as some standard error. So if I were to run this script, and we'll send this to foo4.txt. All right, we see that we have our standard error that came out, and the standard output went to the file. And likewise, clear my screen here. If I were to do foo5.txt, we see we have the standard output, and the standard error was redirected to here. And this is where the 2 and 1, I believe, is going to come in. So 2 and 1. I'm going to send this to foo6.txt. Let's see if this does what I think. Nope, didn't do what I thought. All right, so let's say that you're on the exam and you forget about the 2 and 1. So we should be able to do man bash and search. We can use the slash to search for redirect. So redirections here. You can dig through the man pages and such, and hopefully there will be some clue for you. But clearly this is something that I need to review because I haven't done the two. This bothers me because I should know this. So we're gonna do a little experiment here. Is it that? I don't think that's it. Yeah, what that's going to do is send me the and 1 is going to send that to a background job, which we obviously don't want. Man, what is that command that allows you, basically what I'm wanting to do is send the standard error to standard output, and then all of that is going to go wherever it is that I need to go. So let's try this one more time. Man bash. All right, so we have our file descriptors. So that's really what the 1 and the 2, those are file descriptors. And let's see if we have any other information. Here's what I want. Yep, okay. That is correct. That's what I remember. So, and right here you see in the man page itself, this is why you need to know how to get through your documentation on the any of the Red Hat exams, because you will have it available to you. You're not going to be able to use Dr. Google and such, but you are going to be able to have your man pages and such. So, yep, this is what I was thinking of. So ls to there, and I see. So there's our 2 and 1. That does both standard output and standard error to the file, while that is only going to give us standard output, but the standard error was duplicated from standard output, it was redirected. Okay, that makes sense. So now let's try this once again. We want to do our test.sh. We want to send it to foo8.txt, and 2 and 1. All right, cat foo8.txt, and that gets us what we want. So, man pages to the rescue. That'll be useful for the exam. Now you might be thinking, "Oh, Eddie, you're totally ill prepared for RHCE." No, I'm not. I think I'm pretty well ready to go, especially when we get to some of these other things. But this, if you're preparing yourself, this is why you do a final review, and this is why you go back through some of the objectives that you probably haven't touched in a while, especially RHCE SA stuff, to get that back in your head. I can't obviously guarantee this, but I'm fairly certain when I get to the exam, I'm probably not going to forget this 2 and 1 thing, because, I feel like I've embarrassed myself on YouTube and I had to look it up. So therefore it's going to stick in my head. A couple of other things on the input output redirection. We can use the pipe. And the idea of the pipe is you're going to send your standard output to something else to be processed, such as if we were to do our actually, let's edit the test.sh real quick. I'm going to change this to just ls. So that way we have 2 things that are functioning for us. So that particular script is giving us this output. And let's say that I only wanted to find instances where the word Eddie appears. So I can pipe that to grep and look for Eddie, and it'll show us the results of that. And the idea behind this is that I guess maybe redirection is not quite the correct word, but it is taking this output and funneling it to somewhere else to be processed, rather than just immediately going out to the to standard out. Now there are some commands like the T command that will allow you to send some stuff over the pipeline and it comes out via standard out. That's a command that you can look up to be able to do some more advanced input output redirection. The last thing is the input redirection, and so for this one I honestly rarely ever use this. I haven't had any use cases for it to be. I know it's an important thing and you have to be able to understand it. The most common use case that I've heard of this is if you're doing something with a database, you can use this input redirection to send data back to your database. Let's say that you do a dump of MySQL database. You would basically have whatever your MySQL command is, input redirection, the data, and that will direct that data into that command. So it's basically going in the opposite direction as your output redirection. Another thing under the understand and use essential tools is using grep and regular expressions to analyze text. So you just saw an example of grep there with the with using the pipe. another thing that you'll need to be able to do is understand some basic regular expressions with that. And some of the common ones that I see with grep are using the $sign and the caret symbol. So I'm going to show those to you real quick. Let's go into the var log directory. This will give us some stuff here, and let's tail the boot.log, of course. Let's see, ls-l, what can I read? I can read, let's see, okay, I can read kdump.log. All right, so let's tail kdump.log. All right, so that gives us some stuff here. And let's say that we have several lines here. Let's say that we want to get all the lines that start with try, and we want to use grep for this. So we can do grep, and we're going to do the caret symbol and try. Then we'll give it our file name, kdump.log. All right, and that gives us all of the lines in that log that began with try, and there's a ton of them. Actually, we could pipe that to word count, and I think the -l command tells you how many lines. So there were 30 instances of lines that start with try in kdump.log. Likewise, we can use our $sign. I'm going to do decompression dot and then our $sign. And so I believe what this is going to do is give us lines that are ending with decompression. So let's get rid of our pipe here. And let's give it a shot. Yep, that's what we have. And if I were to word count that to L, it's probably going to be the same number of lines because it would make sense. Now, there's all sorts of regular expressions that you can go to. I'm not going to dive into that much, but let's say that you're on the exam and you need to look up a regular expression. I am fairly sure the grep man pages are going to give you some regular expressions to be able to look at. Notice I searched for regular and it says BRE, see below. So let's search for BRE, basic regular expressions. Does it give us any more? No. But I am fairly sure in this man page, yep, here we go. All right, so we have question mark, star, and such in there. I believe it'll give you some other regular expressions as well, if I recall off the top of my head. But that would be definitely something that I would spend a little bit more time on prior to taking the exam. The goal of RHCE is not that you have a bunch of stuff memorized. You obviously need to have a good working knowledge of whatever tasks and such that you need to be able to do. But I personally, and this is what I'm going to do as part of my preparation, I think it'll be helpful for me shortly before the exam to just kind of go over a couple of common regular expressions like the caret, like the $sign, and a couple of other ones that that would match multiple characters. Or let's say that you have something that's like grep. Let's do tail kdump. Just I want to see what some of my options are. And let's say that I want something that has grep, and we'll do DE V or uppercase V ICE in the line. And what this is doing, that bracket VV is basically saying match anything that is, lowercase v or uppercase v. That's an example of some of the regular expressions you can do. There is one other thing I wanted to point out with grep, and I believe this is the -v flag for that. We'll put it to the test here. Actually, there's two things I wanted to point out with grep. Yeah, so -v gives you the inverse, which is everything that doesn't match whatever you have told it. Another one, and this is one I use a lot, is -I, which means case insensitive. You can also do -E and do some much more advanced regular expressions. But again, for this review, I'm not going to dive a whole lot into regular expressions. Another essential tool that you have to be able to do is access remote systems using SSH. And I've set up a couple of other VMs that I can SSH to from here. And really the basic thing that you would do with this to access via SSH is simply use SSH, whatever user you're going to use. And if you don't specify user, it's going to assume your current user for your bash session. I've set up an admin account for these servers, and you're going to do this at whatever your host name or IP address is. I happen to have DNS running in my lab, so I can use my host name, labrel svr01. Actually, I'm going to do IP address first because there's something I want to show you. 80.5, and then we'll feed it a password. I guess it's already done that. So the very first time you SSH into something, it's going to ask if you want to trust the fingerprint that server is giving you, and you will typically say yes, and that's going to be saved. If I were to cat SSH known hosts, pretty sure. Odd. Oh, I know. SSH. Yep, I'm already on the server. What am I thinking? So let's try this again. cat.ssh known hosts. And you can see that server that we were connected to, I've already trusted its fingerprint, so that's why we weren't prompted for that. But otherwise, again, SSH your username at the host that you want. Feed it a password, and you're in. One other thing you need to be aware of is being able to use key-based authentication. So rather than using passwords, you would simply use SSH keys. And the way that we do that, we have to generate a key pair. So you're going to have a public key that you are handing out to whatever servers that you eventually are going to use key-based authentication for. And you're going to have a private key that stays on your computer. And so when you are doing that SSH connection and your public key is being presented, you will also be using the private key that's actually on your machine. And if that public key and private key pair match what they need to match, then you're able to do that SSH session. And as far as the remote server, you can configure that to not allow password communication, which I guess I can demonstrate that, and just use SSH keys. And that's where, on the server side of it, it'll say, hey, this public key that's being given to me doesn't match the keys that I accept. And if yes, then we're good to go. That's a very probably oversimplified explanation of how the key pair stuff works with SSH, but you get the idea behind it. So step one, if we want to generate our key on our server, we're going to do SSH SSH keygen, and it will ask you where you want to save this. And we're just going to use the, I'm on that server, aren't I? Yep. Am I? Well, we'll see. No, I'm not. No, I am on it. Okay. Forgive me, I got confused for just a moment. We're not going to leave it with a passphrase. We'll deal with passphrases in a moment. So on this server 1, forgive my brain fart for just a moment, we now have a key. And if I were to go into the hidden SSH directory, we have both ID RSA, which is our private key, and .pub, which is our public key. So, made our key. Let's say that we want to connect, I'm on server 1 from server 2 using just SSH keys. Well, we can use the SSH copy ID command. We'll do admin at the server name. This is the fingerprint I was telling you about. We'll say yes. We will feed it our password. And it says number of keys added 1, try logging in. So once you have that SSH key, all you have to do, or once you have the public key copied over to the other server, all you have to do is SSH Eddie admin or whatever username that you want at your host name. And you log in. Notice we're now on SVR02. You log in without having to use your password. So let's say that you wanted to further lock this down to where you would only be able to use key-based authentication. To make that happen, we're here on server 2. We're going to go to our Etsy directory. We're going to go into SSH, or so I thought. No, of course, not /SSH. And within the Etsy SSH directory, let me clear my screen here, give you the path that we're in. We're going to go into sshd.conf. Now I'm going to do sudo vi because this is not the actual root account. I'm going to need to give myself root privileges to change this. And once we're in, there are a couple lines that we're looking for. One, this is something that you can do to further lock down your system. You can turn this to no, which would prevent you being able to use SSH with just the root account. But as far as key-based authentication, what you're looking for is this password authentication. And what we want to do is change this password authentication to no. Once you do that and you restart your SSH service, now only users that are using a valid key are going to be able to log into this server. And how the server knows that a key is valid, let me quit out of this, go back to my home directory, and we're going to go into the SSH hidden folder, and we see a file called authorized keys. If I were to cat that out, you see the public key that was shared from server 1 into server 2. This is how server 2 knows if this key is a valid thing to use. Let's exit out of this. Keep exiting out. And now we're back on our original computer, so LabRel PC01. Another thing that you're going to need to do is switch users and multi-user targets. So this would be using the su command for substitute user. And so let's SSH back into one of our servers. All right, and we're going to create a new user account. And we'll just call it test1. And we're going to give it a password. Test1 is the user account. No. Its password is monkey123, and of course I would fat finger it. All right, so we've made a new user account. We've given it a password. If we wanted to switch to a user and a multi-user target, now we're in a graphical. Actually, no, we are in a multi-user target because we have logged into SVR01. So to be able to do that, we can use the su command. You can do just su and the user account. Oops. And this is going to literally just start a session for you for that user. It is not a login session. So if you are using your bash profile and such for the users, that stuff is not going to be applied here. So if I were to exit this and do su-l test user 1, this is actually going to do a login prompt. And notice that we are now in that user's home directory, whereas before we were still in the directory that we were in prior to using substitute user or su, but we were simply logged in as the other user. So we can exit to go out of that. Let's see, other essential tools. We have to deal with compression, and that's going to be using tar, gzip, also bzip2. There's a command called star as well, which is kind of like tar, that gives you a little bit more flexibility, and especially when you're extracting stuff, can save you from overwriting things. I personally never use star. It's not that it's a bad thing. I've always used tar for that. So to give us an example, let's see, let's go back to our var log directory. And we want to, let's see, let's copy the DNF log to our temp directory. So we'll go to temp, we have our DNF log, and that DNF log is about 43 kilobytes. All right, so if we needed to compress that, we can use a program called gzip, and we simply use gzip, the file that you have. Odd. I understand why, because we're going to change ownership of this. So chown, I actually have to use sudo for that because I'm changing it from root. Okay, so let's try this once again. So gzip dnf.log. Of course, it already exists. Do we want to overwrite? Yes. So we see that this went from 43 kilobytes to 4.7 kilobytes. Notice that it appended the gz to this. We can expand this or extract it by using gunzip is one way of doing that. And that brings us back to our original log here. And I think gzip, is it gzip-u for that? Let's check the man page real quick. So let's say you don't have gunzip. I've always used gunzip. Well, there's D. Maybe it was D instead of U. Yep. But again, I'll always use gunzip versus gzip. You can also use bzip2 for compression, that and that will usually end with a file extension of bz2. There's a different type of compression. I tend to find gzip a little bit more often than bzip2, and there's others. There's, I think, xz is a compression, if I remember off the top of my head. Now that is just compressing files. If we wanted to make an archive is turning a bunch of files into a single file, but it's not necessarily compressing it. What we will do there is use the tar command. So let us do this here. So we have our temp directory. We're going to do tar dash C for create. I like doing V for verbose, and ending with F for file. Ending with F is important. We are going to name this temp.tar, and I'm going to do a star. So that should grab everything and put this into here. Of course, we have some permission issues. So let's do this real quick. I'm going to make a temp folder. Let's go into temp, and we're going to touch several files here. All right, so we have file 1, file 2, file 3. This will keep us from dealing with some permission errors. So let's try this again. We're going to do tar.cvf. We're going to call it temp.tar, and we're going to say everything. And we see we now have a temp.tar file in addition to our 3 files that we had before. You can do tar dash, I think it's dash T, let's find out, T and then F temp.tar, and that's going to tell us what we have in our archive. Now if I were to remove any file here, but then I do tar xzcf, or X for extract v, I don't need to do c because I'm not creating something, f temp.tar, we see that our files are back. Now, you can do kind of a one fell swoop of tarring stuff together and compressing it, and we do that with the -z option with tar. So if I were to do this again, so tar, I'm going to add z, create verbose file. We're going to call it temptar.gz for gzip, because the z, I think the -j flag will send it through bzip2 compression, but z will give you the gzip compression, and we'll do file star. I think that's going to give us what I want. Yep, and we see that this is actually much smaller than the tar files, only 144 bytes versus 10 kilobytes, and we have the tar.temp.gz. So another essential tool that you need to be able to work with are editing text files. And you've seen me use the VI text editor a good bit so far. I'm not going to demonstrate it really anymore, or I guess I can do that with VI. So let's VI into file 1. So I tend to use VI for a good bit of stuff. I always make the joke, VI is my text Lord and Savior. I don't have any problems with other text editors. I just tend to use VI more often than anything here. So if you are using VI and you have your text file here, you would press I to go into insert mode. When you just open it, you're in command mode. So I for insert, and then you can put in all the text that you want. When you're finished, you press escape to go back to command mode, and there are a couple of ways of writing the file and exiting. I like doing :X, which both writes the file and exits at the same time. But you can also do :W, which just writes the file, and :WQ, which writes the file and quit. And I think some folks just press ZZ, that does the same as :X. I learned :X way back when. Let's say that you have your file here and you've done stuff, but you don't actually want to save it. If you were to just do Q, it's going to complain because it says there's been no write to the file since the last change. So instead, you'll do :Q and the exclamation point to override that, and that will get you out of your file. And if I were to cat file 2 again, we see that it is still empty. Another essential tool is being able to make, delete, copy, move files and directories. Well, you saw me use the touch command earlier. That will simply create you an empty file. Touch is really used to manipulate timestamps and such, but it also has a secondary function of creating a file. You can use VI to make a text file, VI file name, and that will make a file and such for you. For making directories, we're going to do mkdir. You saw me do that earlier to create the temp file folder or directory, I should say, that we're currently in now. One thing for mkdir, I believe we'll do man just to make 100% sure. Mkdir, yep, -p. Let's say that you wanted to create a directory and several children. So we'll do mkdir -p parent child1 child2. The -p command will allow you to do that. Otherwise, it's going to complain when you try to create child1 child2 that parent doesn't exist. If I were to do ls-r parent, we see that the children are there with that parent directory. To delete a directory, if it's empty, you can use rmdir. So if I were to try that with parent, it's going to complain that it's not empty. If you have a directory that has stuff in it, you will use rm-r, which is recursive. And that will blow away everything. You see that parent is gone. You can also do -rf, which forces that. I think if you're as root, rm is actually aliased to rm. Oh, I can't remember what the dash is, but it's basically, it does rm, but it asks you, are you sure? You can use f to ignore that. But I would say in general, unless you are 100% sure you want something to be blown away and you can't get it back, avoid using -f with rm. Other things that we need to be able to do are copy and move some items. So we're in my temp directory here. I'm going to copy file 1 over to the next directory up. To be able to do that, we use the cp command, file 1. Let's say I've forgotten the actual name of the next directory up. You can do the 2 dots, which stand for that. Then if we were to ls the 2 dots, we see that file 1 has appeared. Now, of course, copy is going to make a copy of said file. It's not going to actually move the file away. You're going to have two different files to work with. And there are a couple of other options that you can do with copy that will manipulate the permissions and such of a file as well. Moving, on the other hand, literally moves the file. So if I were to mv file 2 up to the next directory, VM. I'm sure if you're watching the video, you're going, yeah, that's not going to work, Eddie. You have to do mv. So mv file 2 to the next directory. We see file 2 is gone. And if I were to ls the next directory, we see that file 2 is there. mv is also what you would use to change a file name. So if I were to want to change file 1 to file 5 or fill 5, mv is the way to do that. Another essential tool is working with file links, and the 2 types of links that you'll be working with in a Linux system are going to be soft links and hard links. A soft link works very much like a shortcut if you're coming from the Windows world, and I'm going to vi fill 5. We're going to add, we still have some text there. Excellent. So I'm going to create a soft link, and I'm just going to call it link to fill 5. Now, link is something that always messes with my head because it's like the order of your stuff is always the opposite of tar. So let's see if I remember correctly. So ln is the command for making links. We want to do a soft link, or also called a symbolic link. And what we want is the destination, which is fill 5, and then the name of the link, which is link to fill 5. Hallelujah, I did it right. See, tar is the name of the file and then the stuff to put into it, and link is the destination and then the name of the link, the thing that you're making. So that always messes with my head, and so I happen to get it right. This is one of these that I usually will double check myself with the man page on. So if you notice with ls-l, it shows us where that link is going to. And notice the permissions. This does not mean that this is like 777 for the actual file, but the link itself is. If I were to cat the link, it gives me what's in the file. If I were to vi into the link, and we're going to add another line, and save that. If I were to cat the link again, we see the other line. So that link is literally saying, hey, I'm actually touching this file. Now, if you were to delete this file, the link is still there, but the link is now broken. So you can fix this by simply making another file. So touch fill 5. And we see that the link is restored. Now, of course, the text that was in that's gone, but from the link's perspective, what it wanted is now back to what we need. The other type of link is a hard link, and this gets into inodes for files. So if you notice when I did ls-l, there's a 1 for a lot of these, and what that's showing you is that there's a single inode for this file. I'm fairly sure I'm doing that right. If I'm saying it wrong, feel free, and this is true for anything in these practice session videos, feel free to leave a comment saying, Eddie, you're wrong about something, because A, I want to get it right for my exam, and B, if people are watching the video, they would want to get the accurate information as well. So don't hesitate to do that. Anyway, an inode is, as far as file systems are concerned, it basically is a descriptor for and I may be oversimplifying this as well, a descriptor for a file. And so that inode is pointing you to like where the blocks of data actually are. And so as long as a file has at least one inode, then that file still exists. So let's take a look at man ls. I want to think it's -i to see the inodes. Maybe wrong. Yep, it is -i. So if I were to do ls-li, I'm doing li to give you the long listing. We see the inode numbers for this. And notice that the fill5 and link to fill5 have two different inode numbers. Now if I were to do ln and we want our destination fill5 and we're going to call the link fill6, notice I did not do the -s this time. And if I were to do ls-li, we see that fill5 and fill6 have the same inode number. And also notice that this column here incremented to 2. So I was right about that being the number of inodes. So if I were to cat fill5, obviously there's nothing in fill5. Cat fill6 should be nothing there. If I were to vi fill6 and add some text, cat fill5, that text is there because both of these files are pointing to the same inode. If I were to change permissions, let's say on fill5, I'm just going to do we'll do 444 for fill5. We see that the permissions have also changed for fill6. So basically, as long as there's at least one inode for something, the file still exists. I myself have typically been using symbolic links more than hard links. One thing with symbolic links is they can traverse file systems. You can basically shortcut to another file system. You can't do that with hard links because we're working with inodes. But it's important to understand the difference between those hard and soft links. Speaking of what we did there, another thing that you have to be able to do is to work with standard permissions. And notice I did 444 for file 5, and that gives us that's using octal notation where the execute permission is a 1, the write permission is a 2, and the read permission is a 4. So 444 for a file is saying I want to have the user, the group, and then everybody else, or the user owner, or let me say this again, the owner, the group owner, and others. 444 means that each of them can read. Now I could also do, let's see, change mode is the command that we do for this. Let's do u plus x file 5. Fill 5. And notice now we have r-x for Eddie admin, the user. I have added the execute permission for that. You can leave out the O and just do plus X, and that's going to give execution permissions to user group and other. You can do -x for that as well. There's another thing with change mode. Let's take a look at the man page real quick for this. You have a couple of things with -r. Capital -r for recursive, and I remember there was one other thing that dealt, this is it, yep. So notice how each mode is in the form of user group, other, or all, and notice how you have this -x that's capitalized. That, if I recall correctly, means that this is only going to give execute permissions to directories. Directories have to have execute permissions in order to traverse into them, and I'm pretty sure they have to have execute permissions to list their contents. I may be wrong on that one, but I do know to enter a directory it has to have execute permissions. So doing the plus capital X can be a way of, if you're doing that recursively for a folder, that will allow you to be able to have all the folders that come after that or further down in the tree having execute permissions and such. And the last thing from the old RHCSA Understand and Use Essentials tools is talking about being able to locate and read documentation, including man info and some of the files. So you've seen me use man a good bit. You can also do info, which technically is the wave of the future as far as documentation. This has a bit of hypertext as far as you can jump to various things with it. I tend to use man more often than not, but info is a thing. The thing about info is if there is no actual info page for something and you use info for a command, it will default back to the actual man pages. The other thing I wanted to show you under user share doc. So user share doc will typically have a folder for pretty much every application that you have on your machine. For example, let's go into tar. So show you my directory here, and within the tar directory you will often find a readme, and you'll find some other information that might not be available to you on man pages. A lot of times you might find examples of configuration files and such in user share. So it is a good resource for documentation, because remember, on your exam you're not going to be able to consult Dr. Google, but you can consult man pages and all of these other things. Now this was a ton of material and I blew through it pretty quickly, and that's kind of by design, because the first set of objectives on RHCE really are make sure you understand the stuff from RHCSA. Well, if you struggle with these basic things, like I struggled with the redirection earlier with that 2 and 1, then you definitely need to review them prior to your exam. But in my opinion, if you're preparing for the RHCE, you should be able to have a pretty good understanding of this old RHCSA content and be able to go through it quickly and give a quick explanation of it. So I want to thank you for taking the time to watch. If you have any comments, feel free to leave them with the video. If you have questions, I'll try to answer them as I have both time and ability. Or if you have any other critiques or words of praise, I accept that as well. I again want to thank returning subscribers for watching another video, and encourage you, if you haven't subscribed to the channel yet, to click that subscribe button and ring the bell when you do. And feel free to share this video with others if you think it'll be useful, and don't forget to like the video if you enjoyed the content. Thanks again for taking the time to watch, and I'll see you the next time.